there again and welcome. I'm Chemcracker and today we are looking at the ionization of water. Now, pure water dissociates to a very small extent to produce hydrogen ions and hydroxide ions as shown. Now we can write an equilibrium constant for this reaction here. Ka for this would be equal to the concentration of H plus ions times the concentration of OH minus ions over the concentration of water. Now, since water is a pure liquid, its concentration is a constant. So I'm going to move this constant over to the other side where the constant Ka is and rewrite the equation. So when we rewrite the equation, Ka times H2O concentration is equal to the product of the H plus ions and the OH minus ions. But Ka times H2O is all one big constant that we put together and we call Kw. Right, so Kw, it will be equal to the product of the hydrogen ion concentration and the hydroxide ion concentration. Kw is known as the ionic product of water, and it stays constant as long as the temperature is at 25 degrees Celsius. This is a very important equation for you to remember. Kw equal the product of H plus concentration and the hydroxide ion concentration at 25 degrees Celsius. Now Kw has actually been determined and its value is 1 times 10 to the minus 14 mole per dm cube all squared, which means mole squared dm to the minus 6 or capital M squared at 25 degrees Celsius. So this value will remain 1 times 10 to the minus 14 at 25 degrees Celsius. Now because of that, we can use that to determine both the hydrogen ion concentration and the hydroxide ion concentration of any aqueous solution. Because for any aqueous solution, this system, H2O goes to H plus plus OH minus, remains in equilibrium. And so it doesn't matter if this solution is acidic, alkaline, or neutral. Once we know the concentration of the H plus, we can calculate the concentration of the OH minus or vice versa. Let's look at this example. The example says calculate the hydroxide ion concentration of 0.01 molar HCl. Now HCl is a strong acid, therefore it dissociates fully in aqueous solution and it dissociates in a 1 mole to 1 mole ratio in terms of the HCl molecules to H plus ions. Therefore, if my original HCl concentration is 0.01 molar, then it means that my hydrogen ion concentration will be the same 0.01 molar. Therefore, we have the hydrogen ion concentration. Now, the question asks actually for the hydroxide ion concentration. But we know that Kw is equal to hydrogen ion concentration times hydroxide ion concentration. So therefore, we can write that OH minus ion concentration is equal to Kw divided by the hydrogen ion concentration. And if we substitute those values into that equation, then 1 times 10 to the minus 14 over 0.01, and that's going to give us 1 times 10 to the minus 12 mole per dm cube for the concentration of the hydroxide ion. I want to introduce you to a term called pOH. Now, we already know what pH is, and the P simply means minus log, so it's just a mathematical operation. So pOH actually means minus log the OH minus ion concentration. That is pOH. Now, This can come in useful when we consider solutions that are acidic or basic and we want to find the pH, particularly when the solution is basic. Now remember this equation here, H plus times OH minus concentration is equal to Kw, which is 1 times 10 to the minus 14 at 25 degrees Celsius. Now if we multiply both sides by minus log, we get, alright, minus log 1 times 10 to the minus 14 would be equal to minus log H plus plus minus log OH minus. Now what that means therefore that this will become to 14, and minus log H plus is basically pH, and minus log OH minus is POH. So from this equation we can see that if we increase pH, right, then POH will decrease because this is a constant 14. So the pH plus the POH equal 14. If I know the pH, I can find the POH. If I know the POH, I can find the pH quickly. So from this we can see the lower the pH, the higher POH, and the higher the acidity of the substance. And vice versa is correct as well. The higher the pH, the lower POH, and the higher the alkalinity. Thank you for watching Chemcracker. See you next time.